in terms of direction. Special report. Climate crisis Japan also faces. We are pleased to have Ishii Masao, Senior Director for Research Affairs, Meteorological Research Institute, JMA. August, IPCC issued AR keeping the surface average temperature increase under 1.5 degrees. The urgency of this Paris target was shown once again. Ishii-san was the lead author of the 5th chapter of this AR, specializes in evaluation research of CO2 absorption by ocean. Ishii-san, the floor is yours.
Thank you for the kind introduction. I am Ishii from the Meteorological Research Institute, JMA. As was just introduced, I will talk about the 6th assessment report, Working Group 1, which was issued in August, based on that contents, and also what JMA has issued based on the government data. I will talk about the climate change situation that the world and Japan is facing. First, this is the important message from the IPCC. The recent CO2 level in the atmosphere is the highest in the last 2 million years, and the rate of increase is unprecedented. On the left-hand side of the graph, so this is the glacial and the interglacial period. In the last 800,000 until quite recently, this is the CO2 level in the atmosphere, and this is the change. As you can see, during the glacial period, low level, and high CO2 during the interglacial period. So there has been ups and downs of CO2 level between the glacial and the interglacial, which means the CO2 level and global warming, or the link between climate, is observed to be very close. If you look at the middle of the graph, where it says 0 to 1000. So within this interglacial period and prior to the Industrial Revolution, as you can see, according to the graph, it's like 280 ppm, roughly. We know that, but on the right-hand side, now entering the 20th century, and in particular from the mid-20th century, there's a sudden rise in the CO2 level. And already by 2019, that's 409.9 compared to 280 prior to the Industrial Revolution. That's an increase almost by 50%. Unfortunately, CO2 level has no color, odorless. We cannot feel it. This is only a theoretical scientific measurement, but if we can smell or see the color, then very obviously we would feel the rise in the CO2 visibly and palpably. But why is CO2 rising? No need to tell you. By human industrial activities, a huge amount of CO2 has been emitted. That's the only reason. Another graph from the end of the 19th century until recently, this is the annual CO2 emission and how it has increased. In particular, from around 1960, all of a sudden, there is a rapid rise in the emission. In particular, more recently, like 2019, the total emission is close to 12 billion tons. So this is only CO2 equivalent. So there could be different data, but 112 billion is a massive amount. And by the way, there is the global population also on the same graph, which is close to 8 billion. That is the reality. As CO2 emission increases, the global population rise. Both are increasing almost proportionately. To put it simply, the global population per capita, 1.5 ton per capita is emitted. 1.5 ton per capita, it sounds like huge if you think about charcoal. Charcoal, 1.5 ton emitted per capita per single person. It sounds huge, but it is huge. In the case of Japan, about 2.5 ton per capita per single Japanese is emitted. As a result, what has happened? Of course, global warming. The human impact in the last 2,000 years at least has caused the Earth to warm at an unprecedented speed. This graph starts from 1850 until last year, which means that around the time of Industrial Revolution, starting from the Industrial Revolution, this is the annual rise in the global temperature. The black line is the observed temperature. This is the actual observed temperature. According to the observation in the last decade, from 2011 to 2020, the average, compared to the average of 1850 to 1900, it has increased to close to 1.1 degrees Celsius, according to observation. Also on this graph, there's a blue line and an orange line. Last week, indeed, Professor Shukuro Manabe was awarded the Nobel Prize in Physics. So climate model is operated by supercomputers, and this is the outcome. The blue line indicates that if there is only nature-related factors, then global warming almost would not have occurred, according to the simulation. But the red and the pink indicates that a human influence, if that is also incorporated and used the climate simulation by supercomputers, then the result is a similar global warming, exactly like what we are observing in reality. So these data tells us that today's global warming is anthropogenic activities related to CO2 emission. CO2 emission and the global average temperature, what is the relationship between the two? This is rather a busy slide. On the left-hand side, the bottom, please look at the blackish part. So horizontally, this is the total emission, not per year. It is the total accumulated emission. Vertically, this is the rise of temperature. So far, the human being has emitted 665 billion tons. A massive, huge amount of emission has been made. As a result, close to 1.1 degrees Celsius has risen. This is according to statistics and observation. What is interesting, the CO2 emission and the rise of the temperature are almost proportional in relation. Then, if we try to plot towards the future, the Paris Agreement calls for suppressing the rise to 1.5, then how much remaining carbon budget do we have? And in fact, you look at the blue characters, and 140 billion tons. This is the estimated amount, 140 billion tons. Earlier, I discussed about the annual emission, which is like 12 billion tons. That's going to be eliminated within 10 years or so. But if we target rise up to 2.0, then of course the numbers are uncertain, but still the remaining budget will be about 370 billion tons. But we will only have 10 plus few years in order to consume and eliminate all that budget. And of course, Japan is also warming. On the left-hand side, this is the annual Japanese temperature and the deviation. There is urbanization in major cities, but those are eliminated. Before 1900, from the Meiji era on the left-hand side, data has been accumulated in this way. It's not exactly linear. Although there are little ups and downs, there are cycles, but on the longer-term trend, very clearly, Japan's temperature is rising per century to 1.26 degrees has risen. The Japanese average temperature rising 1.26 degrees per century. On the right-hand side above, this is where the maximum temperature of the day is 35 degrees or higher, very hot day. And right-hand side below is the lowest temperature is higher than 25, very hot night. Again, very hot night, very hot days, extremely hot days, they are clearly rising in your daily lives. I'm sure that all of you feel that the days are becoming hotter, that even at night it does not cool down. And the actual observation tells us clearly, so warming is progressing in Japan and extreme hot days are increasing. By the way, JMA and the Ministry of Education, these data and information are publicly available, so please do access our information. And rainfall, yes, very problematic rainfall. The annual precipitation in Japan, as is shown on the left-hand side, the annual rainfall, there is not much change per year. More than the temperature, the rainfall is different per year, so long-term trend is difficult to analyze, but signal noise is rather small. SN ratio is small, so long-term trend is not that clear. But if you look at the graphs on the right-hand side, torrential rain per day or short-term intensive rain, these frequencies are rising. On the above, that's 100 millimeters more rain per day. How many locations have experienced this? And there are ups and downs, but the overall trend is rising. And intensive rain in a short term, like 50 millimeters or more rain per single hour. Again, you can see the red line rising. I'm sure that many of you already are feeling this in your daily lives. And again, the observation data clearly backs our experience up. In our daily lives, we may not feel this, but there are other scientific indicators that can be observed. We may not see or feel this, but typically there are lots of phenomena occurring in the ocean. This graph shows how much energy or heat inventory is piling up on the Earth, including the sea. On the left-hand side, from 1970 until recently, this is the energy inventory. The blue, upper blue part, which is the energy inventory in the ocean. This indicates that due to global warming, the energy inventory, the heat piled up, 90% is kept in the ocean. Earlier, I mentioned about the rise in temperature, but the heat, it's only about 1% that remains in the atmosphere. Talking about global warming, that is almost equal to rise in the sea water temperature. As a result, what happens? First of all, needless to say, but the sea surface temperature rises, meaning the sea becomes warmer. On the left-hand side above, this is the average sea surface temperature across the world. So from 1900, more than 100 years ago, we started the observation. On average, per 100 years, 0.56 degrees increase. Very clearly, sea is becoming warmer. And left-hand side below, this is the average sea surface temperature in the coastal sea of Japan. Unlike the world average, there is a larger ups and downs. But the point is, it is rising. Very clearly, the sea is becoming warmer and much faster. Per century, it is rising by 1.16 degrees, much faster than the global warming. And it is very similar to the temperature rise. 1.24 degrees per century is rising. So the temperature rise and the sea surface temperature rise in the sea surrounding Japan shows very similar patterns. On the right-hand side, this shows the abnormal high temperature heat wave in the sea occurring in the sea. And August last year, it was summer and very high temperature. So close to Japan, including southern part of Hokkaido, of Sanriku on the Pacific side, the southern part of Honshu, Tsushima Strait, a part of Japan Sea, very close to Japan. In particular, in August last year, the sea water was so warm. Extremely warm seawater is occurring across the world. Impact occurs on the fishery, onto the climate. There are major impacts because of the rising sea water temperature. And the second large issue, which is the ocean warming, which causes sea level to rise. On the left-hand side, close to what you saw earlier, but from the 1970s, when the sea level started to rise, this shows the average rise in the sea level, and the broken line is the observation. From 1970, in the 50 years or so, the global sea level has increased by 10 centimeters or so already. Why? the sea water becomes warmer and there is seawater thermal expansion. That accounts for 50% of the rise. In addition to that, in Greenland, Antarctica, in the mountains, the ice and snow melts, and those flow into the sea, which brings up the sea level. That's another 50% of the contribution. This trend is expected to continue. On the right-hand side above, look at the yellow graph, and this is the sea level rise surrounding Japan from 1906. We have a history of 100 years of observation. Unlike the left-hand side graph, this is up and down, going up and down. This is similar to the sea temperature. But the sea level rise, there are current that impacts, and the sea level changes rapidly. But from 1980s and onwards, if you look at the red line, just like the global sea level rise, the sea surrounding Japan, the sea level is also rising. In the last 40 years or so, close to 1 meter, no, correction, it has risen by 10 centimeters or so.
Next, with scientific eyes, finally we can see another phenomenon. The ocean absorbs approximately a quarter of CO2 released, and then thereby mitigating global warming. Left-hand side, please look at the top graph. I have already shared this with you, CO2 annual emissions. On the bottom, when it's emitted, where do they go, actually? That's shown here. Actually, when it's emitted, not everything remains in, not all the CO2 remains in the atmosphere. The remaining one of emitted is less than 50% of the emitted. So what about the rest? Where do they go? About a quarter is absorbed by the ocean. About 1/3 is absorbed by the forest. Hence, the forest and the ocean absorb more than 50% of the emitted CO2, mitigating CO2 increase and then mitigating global warming. So what's likely to happen going forward? If the CO2 large amount of emission continues, the ratio absorbed by the ocean and forest will decrease. At the volume-wise, it will increase, but the ratio will decrease, meaning that more CO2 will remain in the atmosphere. That means accelerating global warming even more in terms of its effect. As you can see, if you look at the ocean, to mitigate global warming, the ocean plays a very important role. On the other hand, by absorbing CO2 in the surface layers, there's acidification of the ocean. Why is it occurring? When you were in elementary school, perhaps if you dissolve CO2, then you can make a carbonated water, and this is acidic, the weak acidity. So such acidic water, carbonated water, is added to the ocean, with more acidification occurring in the ocean. Center, you can see the surface layer of the ocean's pH, that it's acidic. This is the indicator that we can use, and because of the year or the time of the year, it can change, but pH is about 8 at the surface. 7 is neutral, 8 means a weak alkaline, and then carbonated water is added. That's what's actually happening with this. The seawater is becoming more neutral. In more than 10 posts, long-term observation has been conducted. As you can see, that while there are some differences, as deep blue shows, the pH is coming down, meaning it has become more acidified. Just for your information, near Japan, left-hand side, second from the top, 137 equals 30 degrees north. That's right north, the south of Japan, according to JEMA. Significantly, with the CO2 absorption, there's acidification in near waters of Japan. The waters are becoming acidified. Why is it bad? The acidification, it's called the other CO2 problems, various creatures in the ocean. And the ecosystems that depend on them, they can suffer, are likely to suffer major damages. Left-hand side, This shows coral reef with acidification already with global warming, whitening, and then also as the seawater becomes dirty, there is a bleaching is another issue, loss of diversity, loss of tourist resources, and in various tropical areas, it serves as a dike to protect the habitat for people. With the loss of coral reef, they are exposed to various risks. Various creatures also are affected by the acidification. As you can see, there are some characteristics. Carbonated calcium aragonite is used for their shells or their skeletons. And it becomes difficult for them to live. And the ocean ecosystem as a whole will change, and also it will affect the marine resources, especially those people who depend, countries that depend on the marine resources, including Japan. There's a high likelihood it will develop into a food issue. That's why the acidification is a major concern for us. So going forward, what's likely to happen? Very briefly. Dr. Manabe established a foundation for these studies. Going forward, CO2 emissions, what's likely to happen? Regarding the climate models, CO2 emissions, various scenarios have been created. And what about the changes in the climate? Top left, please look at the graph. From 1950 to 2050, you can see black line. From statistical data, annual emission has been already clarified. Going forward, what's likely to happen? Blue line, emissions very low, few emissions. In terms of CO2 emissions reduction, this is the scenario with a strong reduction. 2050 is close to zero. So this is none other than 2050 carbon neutral scenario. But for instance, looking at those climate models using these scenarios, as you can see on the right-hand side, this is the surface temperature increase over time. 1.5 degrees might be surpassed, but perhaps can be kept at 1.6 at the end of this century, around 1.5. So the Paris target's almost achievable under this model. On the other hand, pH of surface water to show us acidification, it's likely to go down a little, but more damages perhaps can be curbed and prevented. And also the sea level. In any scenario, the increase of sea level will continue, but as emissions are reduced more and more, the sea level increase will be kept lower. Lastly, instead of a summary in this IPCC AL6 message from the Working Group 1, this is message 1. It is unequivocal that human influence has warmed the atmosphere, ocean, and land. It says unequivocal in English. It's stronger than ever in terms of the level of expression. Widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere have occurred. The second message, unless there are immediate, rapid, and large-scale reductions in greenhouse gas emissions, limiting warming to 1.5 degrees will be beyond reach. And the last message for today, the climate we experience in the future depends on our decision now. The word decisions perhaps can be replaced by the word actions. Thank you so much for your kind attention. Ishii-san, thank you so much. With climate change, the role that should be played by ocean, it was a very detailed and very easy to understand presentation. You mentioned action. I think this is open to our next topic, our next session. In the past, we made some decisions, we took some actions. And now, that's why we see what we are now seeing what's happening because of that. And it also has an effect on what's going to happen in the future. So the importance of actions was very clearly indicated by you.